Alright, in this video we're going to finish talking about quadratic equations. In the last video we introduced completing the square. Here's a more advanced example for completing the square. Namely, before we only looked at examples with just a 1 here. Now we're going to go ahead and see what happens when we add in an extra number here. So the way we do this is the first step is go ahead and take the 5 to the other side, as we did before. But now what we're going to do is we're going to go ahead and pull out the 3 before we complete the square. So by pulling out the 3, we have 3 times x squared. Let me move this a little bit higher up. 3x squared minus 3 times x squared minus 4/3 x equals 5. And now what we can do is we can go ahead and complete the square here. The term that we need here is we need 4/3 divided by 2 squared right there. Of course, that is 4/3 divided by 2 is the same thing as 4/3 times 1/2 quantity squared. The 4 and the 2 will cancel, leaving the 2 in the top, a 1 in the denominator. So we get 2/3 squared. 2/3 squared is 4/9. So we go ahead and we say, oh, well, we can add in 4/9. Now, an important thing here is we need to add to this side to keep the equation true. Of course, what we see here is that we're not really just adding in 4/9, we're adding in 3 times 4/9. So let's add in 3 times 4/9 on this side. Doing that, what we have here is, let's go over here. Here we have 3 times, and we know that whatever was on the inside of here, namely the 2/3, is what this reduces down to. So x minus, this was a minus there and a minus there, but it doesn't matter once you square out. But x minus 2/3 squared equals 5 plus this right here is the same thing, 3 and 9, that'll become a 1, that'll become a 3, so we have 4/3. 5 plus 4/3 is, 5 times 3 is 15, so we'd have 15 plus 4 over 3 is 19 over 3. So we have 19 over 3. Now we go ahead and we divide both sides by the 3 here, so we have 19 over 6, x minus 2/3 squared times 19 over 6 equals 19 over 6. Let me just check real quick. 19 over 9, sorry. 9. And that's squared, so now I take my own square root, and I get x minus 2/3 equals plus or minus the square root of 19, because 19 is prime, so I can't do anything with it, divided by the square root of 9, which is 3. Okay, again, I added a plus or minus in because I'm taking my own square root. And so now I add 2/3 to both sides and get that my solution should be x equals 2/3 plus or minus the square root, 2/3 plus or minus the square root of 19 over 3. Of course, since these have common denominators, I can write this as 2/3, I can write this as 2 plus or minus the square root of 19 over 3. Let's check that. Plug that back into the original equation. We have 3 times 2 plus or minus square root of 19 over 3 squared minus 4 times 2 plus or minus root 19 over 3 minus 5. What does that equal? What that equals is here, if we expand this out, the bottom will give us 2 3s. One of those 3s will cancel, so we'll get the 3 in the bottom. In the top, we have to FOIL this out. You would have 4 if you have the plus, you'd have the plus 19 and the 2. You'd have a, yeah, you get the positive and the positive, so you'd have root 19. So yeah, you'd get 2 root 19 plus another 2 root 19, so that'd be plus 4 root 19 plus root 19 times root 19. Well, that'd be plus or minus here. Sorry. Plus or minus 4 root 19. Here you get positive 19 because the square roots would multiply and cancel. Over here then you have minus 4. The minus will go ahead and go in, so let's go ahead and send it in. The 4 in we get plus 4. 4 times 2 is 8. So that's negative 8 minus plus. Yeah, let's put the minus out here. Sorry. So 8 plus or minus 4 root 19 all over 3. And then we have minus 15 over 3. Now, let's go ahead and calculate this out. The 4 root 19, the 4 root 19s over 3, once you put them in the, once you add, subtract those fractions together, those parts would cancel, those plus or minus parts. And then what do we have left? We have 4 plus 19 is 4 plus 19 is 23, minus 8 is 15, and then we have, yeah, so 3, so we have 4 minus 4 plus 19 is what? Oh yeah, no, is positive, yeah. So 4 plus 19 is 23, minus 8 is positive 15, minus another 15 is 0, so this actually does give us 0. Okay. Now let's have you try an example. So go ahead and, following the pattern that I did in the last problem, go ahead and solve 3x squared minus 10x minus 2 equals 0 by the completing the square method. So on the count of 3, I'll go ahead and reveal the answer. 1, 2, 3. So here you can see that we went through, I sectioned it off first, and then I added 100 over 36 using the calculation that we do to figure out the right thing. We know that negative 10 over 6 is on the inside, so that is the inside part of this, so that's going to be the inside part of the perfect square. I go ahead and, remembering to add 3 times 100 over 36, I simplify, and then I end up with, and then I end up with this once I simplify that side, adding the fractions. This side I can go ahead and divide both sides by 3. Then I go ahead and I reduce this down while taking reduce 10 over 6 to 5 over 3 while taking my own square root, so I add in the plus or minus. Then bringing it over here, I add 5/3. I do a little bit of calculation to get this as my solution, and then I go through and I check by plugging in. Foiling out the top, I get this. One of the 3's will cancel, so I have 1 3 left there. Here, distributing the 10, I get this, and that will end up canceling through the difference of sign here. And then, so I end up with 56 minus 50 over 56 over 3 minus 50 over 3 minus 6 over 3, which totals out to 0. So it does actually equal that. An important thing to note here is, if you know the quadratic equation, you notice that this sort of a solution and the solution I got in the example I worked, these solutions look a lot like what you get out of the quadratic formula. So let's go ahead and talk about how you would get the quadratic formula from completing the square, as that is where it comes from. So, as I was said, we can get the quadratic formula from completing the square. The way the real question here is sort of, how do we complete the square to solve the general form of ax squared plus bx plus c equals 0. So this is the general quadratic equation where we have any real numbers a, b, and c, and a does not equal 0. Well, because let's go ahead and try completing the square pretending that these are numbers we know. Well, what did we always do? What we always did is we first took c to the other side, And then what we had is, so we had ax squared plus bx. Of course, since we have a may not be 1, let's go ahead and factor it out. If it were 1, it would just leave things unchanged. So, plus b over a x equals negative c. Now we have to figure out what to add in here. To add in here, we always take whatever the coefficient is here. We divide it by 2. And then we square it. Of course, if we do that, what we get is we get b over 2a quantity squared. And then we get, when we square that, we get b squared over 4a squared. So that goes in here. We add that in there. B squared over 4a squared. Of course, we can't just add stuff willy-nilly into here. We have to add something. We have to add to the other side the same thing. Well, we see that this whole side, what we're adding is we're adding a times that. So that's plus a times b squared over 4a squared. And so one of the a's in the denominator will cancel with that a. Now, if we continue and we get a, so now we know that we can break this down. This creates a perfect square, and it's a perfect square of x plus whatever's on the inside before we squared. So x plus b over 2a squared times a. And now we got to add to this side. If we add to this side, we have to get a common denominator here. So we multiply top and bottom by 4a here. So we get negative 4ac plus b squared all over 4a. Now, let's go ahead and divide both sides by a. If we divide both sides by a, we get x plus b over 2a quantity squared equals b squared. I'm going to go ahead and swap the order of these because it makes it look a little nicer. If you know the quadratic formula, this is where you start to see it come about, the b squared minus 4ac term. Then we have 4a, and since we divide by another a, we get a squared. Now we want to take our own square root. When we take our own square root, we will get x plus b over 2a equals plus or minus the square root of the top and the bottom. Square root of the top we can't really do much with because square roots don't work well with addition and subtraction. But on the bottom, what we can do is we can go ahead and take the square root of this. That will be square root of 4 and square root of a squared. That gives me the following. That would give me 4 times a. A is, okay? But now we go ahead and to finally solve out, we have x equals negative b over 2a plus or minus the square root of b squared minus 4ac. Oh, that was 2a down here. Sorry, when I take the square root. There, from there to there. And that's all over 2a. So in other words, what we can do is we can actually put this together and get that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we actually have the quadratic formula. Namely, we know that if ax squared plus bx plus c equals 0, then x must be negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, now this is a super useful formula if, one, you can remember it, so it's kind of worth memorizing this, and also if you know when to use it. So there is a nice song that sort of goes to Pop Goes the Weasel. However, I've added a little addendum at the very start, which is really nice to contribute to it. So I suggest you know both parts of the song. And so here you go. If ax squared plus bx plus c equals 0, then you have a quadratic equation whose solution is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So hopefully that'll help you remember it. So now let's use the quadratic formula to solve a couple of these equations. So the first thing is we need to put into the correct form. Namely, we need it of the form ax squared plus bx plus c equals 0. This does not have that form yet, but if we take 9 to the other side, it will. Namely, we have x squared plus 3x minus 9 equals 0. Thus, we know that the solutions are x equals negative b. So this is a, this would be b, and this would be c. Again, because in the quadratic formula it's ax squared plus bx plus c. So we have x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 9. All over 2 times a, which is 1. In other words, we have x is equal to negative 3 plus or minus the square root of b squared of the square, so negative 3 plus or minus 9 plus 4, negative 4 and negative 9 give me positive 36. All over 2. Well, that equals negative 3 plus or minus the square root. 9 plus 36 is 45. And now we should try to reduce this radical if possible. We have 45 factors into 5 and 9, so 3 and 3, so we can pull out 2 3's. So the final solution should be x equals negative 3 plus or minus 3 times the square root of 5 over 2. So I'll leave it to you to check that solution works. Let's go ahead and proceed to this example. We have 8x squared, so x equals negative 24. So let's be careful with that. Plus or minus the square root of negative 24 squared. Plus 4 and 4. Actually, before we even begin, trial and error is how math is done after all. Let's divide everything by a common factor if there is one. A common factor of all of this is 8 is not a factor of 18, but 2 is a factor. So if we divide everything by 2 first, we get 4x squared minus 12x plus 9 equals 0. And that's much easier to deal with. So let's go ahead and deal with that. So we have x equals negative b, so negative 12, plus or minus the square root of b squared, so negative 12 squared, minus 4 times a, which is 4 times c, which is 9, all over 2 times a. Simplifying down, we have that this is what? What do we have? This would be 12 plus or minus square root of 144 minus 4 and 4 is 16. 16 times 9. Let's just do that out real quick. 16 times 9, 6 and 9 is 54. 1 and 9 is 9 plus that, so 144. Hey, look at that. That's neat, isn't it? All over 8. So we get 12, so that part actually becomes 0. And then we have 12 over 8. Well, if we reduce down, that would be 4. That would be both are divisible by 4, and so we get 3 over 2. Let's check that. That's worth checking. Checking this, we end up with what? We end up with 3 halves, so we get 8 times 3 halves squared minus 24 times 3 halves plus 18. What does that equal? It should be 0. But if we go ahead and do that out, we get 8 times 9 over 4, so that cancels, becomes a 1. That cancels, becomes a 2. Minus 24 times 2 is going to be 12 times 3. Again, 1 and 12. plus 18. So we end up with 2 times 9 is 18, minus 12 times 3 is 36, minus plus 18. 18 and 18 gives 36, so this whole thing gives 0. And so it works. Now it's time for you to quickly try an example, so go ahead and work the following 2 problems. On the count of 3, I'll reveal both answers. 1, 2, 3. So here are the solutions. Here it works out that the 5, that whatever is under the square root ends up canceling and being 0. So you end up with just the one solution, 4/3, which you can check and make sure is. Over here, you have to make sure to bring the 10 to the other side first. Once you do that, plug in. You end up with these as your solutions. Here, what I actually did from here to here is I factored out a 2 and then canceled with the 6 to get a 3 in the denominator. And then you can go ahead and check to make sure that that's the correct solution as well. For more practice in solving quadratic equations, be sure to see pages A56 and A57, numbers 47 through 72 of the textbook. In our next video, we're going to use what we learned in these last 2 videos to solve polynomial equations of higher degree.